Hi student, welcome to this new video on vector space. We know that for some time now, you have been exposed with the notion of vector either in mathematics or in physics. But basically, a vector is defined as a quantity having a direction as well as a magnitude, especially as determining the position of one point in space relative to another. Now, those were definitions given to you in physics or in mechanics or in simplified math in high school. But here, we want to expose you to a more broader way of defining a vector space. For instance, I bring to your calling that the space Rn consists of all columns vector V having n component, right? For instance, R5 R5 is a space containing all column vectors having 5 components, that is a 5-dimensional space. So R2 will be something like xy, which is defined in a xy plane, right? And R3 will look like this, right? Which is R3 consists of all column vectors with 3 components, and it is called a 3-dimensional space. Okay, so the component of vector V are numbers. That is why we have the R. If the component of V were a complex number, we should have Cn. But because the component of V are real numbers, that's why the space is Rn, R for real. Now, let's define a vector space. We call a set S equals to U, V, W, a vector space and its element. Vectors. If two conditions are satisfied, the first condition is that it is closed under vector addition and closed under scalar multiplication. Okay, so these are the two conditions that needs to be satisfied to have a consistent vector space. For instance, what does that mean? One, what does it mean to be closed under addition? Let's consider this vector 1, 2, 3, and the other one 5, 4, 5, 6. So, and we have that if I add the two, okay, so this will give me 6, 7, 9. Now, we said that a vector space, a set S, U, V, W of vector is called is a vector space and its element vectors if it is closed under vector addition and under scalar multiplication. If you consider these two vectors, let's say these two vectors V1, V2 belong to S, right? So V belong to S, V1 belong to S, and V2 belong to S. And this is V1 plus V2, right? And this is V3. Now, if V1 is in S, V2 in S, if V1 plus V2 given V3 is also in S, therefore, right? Therefore, the first condition is satisfied. That's the meaning of closed under vector addition. It means that if we add two vectors belonging in the set, the resultant vector should also belong in that set. And closed under scalar multiplication means that if, for instance, I have V1, which is 1, 2, 3, and I multiply it by, let's say I take a scalar 2, so I have V2 is 2 1, 2, 3, which is 2, 4, 6. If V2, 2, 4, 6 is also an element of S, because V1 is in S, if this is also in S, it means that our set is closed under vector addition and scalar multiplication. Okay, so if we look at vector addition, so let U equals to A, B, C, and V equal to D, E, F, be element of R3, right? Where we have A, B, C, D, E, F, element of R. If U plus V equals to A plus D, B plus E, C plus F belong to R3, right? Therefore, R3 is closed, right, under vector addition, right? Now, if we consider the scalar multiplication, so if I consider that U is A, B, C, and I consider any scalar and A, B, C, B in R, if alpha U, right, equals to alpha A, B, C, which is alpha A, alpha B, alpha C, which also belong to R3, and U is in R3, then we will say that R3 is what? Is closed under scalar multiplication. Okay, if we have this example here, right, example, and we say that consider the set of polynomial, right, defined as Vx equals to minus 2x squared plus 4x plus 2 and 2x squared plus 4, right? These are the set of polynomial. If we call this one P1, right, we see that P1 belongs to V because this is V, and we call this P2. P2 also belong to V. So the question is that is V, if you want V of X, a vector space? How will you answer that question? So the first thing is that we check if it is closed under addition. This is a check, right? So if we do P1x plus P2x, we have that is minus 2x squared plus 4x plus 2 plus 2x squared plus 4, which this goes, this and this will go. So I will have that it is 4x plus 6. So what do you think? We see that 4x plus 6, if it's a polynomial, of degree 1, right? Meanwhile, our set V is a set of polynomial of degree 2. It means that P1x plus P2x, right, does not belong to V, because V is a set of polynomial of degree 2, and we see that P1 plus P2 is a polynomial of degree 1, therefore it's not element of V. Therefore we say that V is not closed under scalar addition, right? Okay, if we look at this other example 2, we have B equals to A, B, where A and B are superior or equal to 0. The question is that if is B a vector space? So the first thing to do is to check for what? If it is closed under addition, right? Now, if I consider an example, I take V equals to 1, 2, which makes sense because A and B should be positive. So I take V equals to 1, 2, so it belongs to B, right? And if I also take another U equals to 3, 4, so I will see that U plus V will give me 4, right? And 6, which belongs to B. So the addition is being preserved. Let's now check the scalar multiplication. So if we have that V equals to 1, 2. If we take a scalar minus 2, then alpha, right? Alpha V will be equal to minus 2 minus 4, which is not part of B because B should be all the positive element. So we say that B is not a vector space. Why? Because it's not closed on the scalar multiplication. Thank you very much. See you in the next video.